deep industrial hum, distant metallic impacts, massive turbine rumble. Inside this massive factory in France, engineers are building machines so enormous they can carry hundreds of people across entire continents. These flying giants cost more than $300 million each. But what really happens inside the Airbus factory? How do thousands of tons of metal become one of the most advanced machines on Earth? Tonight, we go deep inside the giant industrial world of Airbus, where sparks fly, robots work without rest, and engineering reaches unbelievable levels of precision.
Good, let's proceed
Airbus,
with the stress test analysis.
how $300 million flying giants are built. No factory ambience, ventilation drones, hydraulic movement. Located in Toulouse, France, Airbus operates one of the largest aircraft manufacturing facilities in the world. These assembly halls are so massive, entire apartment buildings could fit inside them. Every year, thousands of engineers, technicians, and robotic systems work together to build some of the most advanced passenger aircraft ever created.
Lower by
From
5
giant
centimeters,
fuselage
very
sections
slowly.
to
We are
wings
almost
longer
aligned.
than a basketball
Confirmed.
court.
The starboard
Every
side is locked in
component must
place.
be assembled with near perfect precision. Because at 35,000 feet, failure is not an option. The heavy cargo movement, forklift beeps, metal impacts. The process begins long before the aircraft takes shape. Massive aluminum sections, titanium components, carbon fiber structures, and precision electronics arrive from factories across Europe. Some aircraft sections are so large they must be transported using specialized ships and oversized cargo aircraft.
Monitor the voltage on the auxiliary
Inside
line,
the logistics
just
center,
forward of the bulkhead.
every part is
Reading
scanned,
stable.
inspected, and
We are
tracked
clear for
digitally
installation.
before entering production. Because even the smallest defect could compromise an aircraft worth hundreds of millions of dollars.
Bring it down another
Robotic
5
arms,
millimeters.
welding crackles,
Reading
hydraulic
confirmed.
pressure.
Clear on this side.
Now, the giant assembly process begins. Inside these cathedral-sized halls, massive robotic systems position aircraft sections with millimeter precision.
Alignment holding
Gigantic
steady at 0
fuselage
tolerance.
structures are slowly
Pressure
joined
nominal.
together, while
Locking
automated
sequence
drilling
complete.
machines install thousands of aerospace rivets. Each hole, each panel, each connection must align perfectly. Some robotic drilling systems are accurate to fractions of a millimeter. One mistake could affect the aerodynamics of the entire aircraft. Overhead cranes weighing hundreds of tons move giant aircraft components through the factory, while engineers constantly monitor
We are
every
approaching
stage
the limit.
using advanced
Maintain
digital
current
systems.
pressure.
This is not ordinary manufacturing. This is aerospace engineering at
The
its
data stream
absolute
shows
limit.
we are within tolerance on
Metallic
the wing assembly.
resonance, servo
Good.
motors,
Let the robots proceed to the
industrial
next
echo.
sequence.
The wings are among the most complex parts of the entire aircraft. Built using lightweight aerospace alloys and carbon fiber composites, these giant structures must remain strong enough to survive extreme turbulence, while still being light enough to fly efficiently. Inside the wing assembly zone, robotic arms carefully install internal support systems, fuel lines, electrical systems, and hydraulic mechanisms. Thousands of individual components are hidden inside a single wing, and every system must function perfectly, because these wings will eventually support hundreds of tons in the sky. Deep turbine rumble, mechanical rotation, air pressure. But the real power of the aircraft comes from its engines. Modern Airbus jet engines are engineering masterpieces. Each turbine contains thousands of precision-built components capable of surviving extreme temperatures and incredible rotational speeds. Inside the propulsion testing chambers, giant turbine blades spin with terrifying force. The sound alone can shake entire buildings. Engineers use AI-driven systems and advanced sensors to detect microscopic imperfections invisible to the human eye. Because at cruising altitude, these engines must operate flawlessly for thousands of hours. Failure is simply unacceptable. Quality control plus testing, 6 o'clock to 7:20. electronic scanner sounds, hydraulic hiss, warning alarms. Before the aircraft can fly, it must survive one final challenge: testing. Every Airbus aircraft undergoes intense structural inspections, digital scanning, pressure testing, and hydraulic stress simulations. The wings are bent under enormous force. Landing gear systems are compressed using giant hydraulic machines, and every onboard system is analyzed by advanced computers. Even the smallest vibration can trigger a full inspection, because safety inside modern aviation depends on absolute precision. Paint plus final reveal, 720 to 820. So make just soft compressed air, echoing hangar sounds. After months of manufacturing, the aircraft finally enters its last transformation: painting. Inside specialized finishing hangars, robotic spray systems coat the aircraft in layers of high-performance aerospace paint. Then, for the very first time, the complete aircraft is revealed, polished, massive, and ready to fly. Under the factory lights, the Airbus finally looks alive.
We have full
Runway
synchronization
testing,
across all
820 to 910. Powerful engine startup, runway ambience, wind pressure. But one final moment remains: the runway tests. Outside the Toulouse facility, pilots and engineers prepare the aircraft for its first real movement. The engines roar to life. Heat waves distort the air behind the turbines. And slowly, this giant machine begins to move. Hundreds of tons of engineering rolling toward the runway. Built by thousands of people inside one of the most advanced factories on Earth. 9:10 to 10. Soft turbine ambience, cinematic rise, wind over clouds. Every Airbus aircraft begins the same way, as raw metal inside a giant industrial world filled with sparks, robots, machines, and human precision. But eventually, these machines leave the factory floor and carry millions of people across the planet, connecting countries, connecting families, connecting the world. And behind every flight is one unbelievable factory. Inside Factory Work. Subscribe for more cinematic factory documentaries.
Transport system is clear on the left side.
Confirmed. We are maintaining present velocity. All systems nominal. We have full green on the PFD and EWD.
Confirmed. Power settings checked.
Retract sequence initiated.
Clear on my side.
We have weight on wheels. All systems green. Proceeding to rollout point 0.
Confirmed. Maintain current vector.
All stations, taxi sequence continuing on schedule.
Affirmative. Speed looks good from here.
Okay, we are at target volume, shutting down pumps now. Please disconnect when ready.
Airbus 76 Heavy, clear to taxi runway 34, wind 290 at 5.
Roger, taxi to 34, 76 Heavy.
Ramp 7, request pushback clearance for flight DL123. Pushback approved, standby frequency 121.9.
V1, rotate. Positive rate, gear up.
Center, Airbus 79er, maintaining flight level 390, currently experiencing light chop.
Runway is clear. All parameters nominal. Final test procedures complete.